Y10 and welcome to your next geography lesson. I'd like you to do a little recap here of your last lesson on hydrographs. Write a label for each letter below. This should take 5 minutes. Write all the key terms and all the information you can remember for each of those. Pause the video now. Okay, answers time. So discharge. Time are our two axes. Rainfall, peak discharge, lag time, rising and falling limbs, the storm flow and the base flow. Please double check those, correct any that you've got wrong, and we shall move on. Okay, so title for today, please, Managing Floods, Hard Engineering. So in the next 2 lessons, we're going to be looking at different ways of managing rivers to try and reduce the risk of flooding. The first set today are called hard engineering methods. We're going to define that and then look at our 4 examples. You need to be able to describe and explain them. Make sure you've got all the equipment, get that title written down, pause the video now. Okay, so a definition of hard engineering. This is where man-made structures are used to prevent or control natural processes from taking place. This is the equivalent of Gandalf standing on the bridge saying to the Balrog, "You shall not pass." This is about stopping what's happening from happening. Jot that down and pause the video now. Okay, so we're going to go through the 4 types of hard engineering now. You've got some explanation and slides from me. You've also got pages 126 and 127 in the textbook, which you could also have open to complete this with. On the next slide, I'm going to show you the table. You can either print it out or just copy it into your book. So this is a table that we're going to be completing for the 4 methods down the left there. We've got how does it work, advantages and disadvantages. There's an expectation here that you will be able to evaluate these and also evaluate these against the 4 we'll learn about next lesson as well. So we need to know what's good and what's not so good about them to be able to do that. And the first one we're going to look at are dams and reservoirs. So you can clearly see this is a very man-made structure, a concrete block across the river, creating that reservoir behind it. That reservoir is not natural. That reservoir is created because this is slowing the river down. And in this particular dam, very impressive dam, you can see the water cascading over the top. Water might also be passing through pipes within the dam in order to flow. And if you look just at the bottom of the screen, I shall put a laser pointer on here, you can actually see the river. Here's the river itself now flowing off. Here you can see some kind of structure, which implies that maybe there's more going on here. Maybe there's some form of energy being created at this dam. This could be a hydroelectric dam as well, creating power from the energy of the water. And here's the writing. Dams are large concrete barriers built across the river. The water behind the dam is stored in an artificial lake known as a reservoir. Water is then gradually released downstream to control the flow of water and reduce flood risk. And that flow of water can be controlled. So if, for example, there was a particularly heavy rainfall, we could slow the amount of water flowing out of this reservoir down so that the river does not flood. Next one, channel straightening. So you can hopefully see here that this river is coming from the bottom here, is naturally meandering round and round, and well, once upon a time would then have come out, and here's the mouth into the sea. But what's happened is we've come along, we've said no, we don't like that process. The water is slowing down too much here, going around all these bends, and it's leading to flooding of this land to either side. So a straightened channel has been artificially carved through, meaning that the water can very rapidly move straight down here and straight out to sea nice and quickly. Now, at some points, this might actually prove a problem, because if there wasn't a mouth here, and if this was, say, a settlement and the river had miles and miles to go still, we could actually be moving the water more rapidly towards this settlement, causing flooding there. But in this case, that isn't the case. This water is just rapidly flowing straight out to sea, where it's not going to harm anyone. So channel straightening involves cutting through meanders, creating straighter channels to speed up the flow of water. And yes, sometimes you can concrete line them as well in order to reduce the amount of erosion on them, and also to speed that water up even more as there's less friction. Okay, embankments. So you've seen something like this before. This looks a lot like what I hope you'll recognize as a levee. So this is just a man-made levee. The idea being that you've raised the banks of the river up, so there's less likely that the water will be able to escape and flow into, in this photograph, into these houses and buildings on either side. So think of it like a wall. It's an earth or a concrete wall built to block the water. There we go, artificially raised banks, increasing the channel capacity to reduce the flood risk, the capacity of water it can hold. Bulldozers are used to build up the height of the banks with impermeable soil, where they pack the soil so closely together that water can't pass through it, or they line them with concrete. If we think about the natural environment and the visual environment, you can see here in the photograph, it's not been massively impacted. But now imagine it was made of concrete. Think back to the dam as well. These are very, very man-made, unnatural looking. Some people would argue that that might be a disadvantage of them. However, something like this, where you've just used earth and grass, looks a lot more natural. It does not look out of place particularly. And the final hard engineering strategy, a flood relief channel. So this is a completely artificially built channel of water. The idea being that if the river starts to fill up, we can divert some of the water through this channel so that the river itself doesn't overflow. An artificially constructed channel designed to be a backup for rivers that frequently flood, bypassing major urban areas. At high flow, a sluice gate is just a gate essentially that holds the water in the river, but when you open it, it can flow out. They're opened, allowing excess water to flow into this channel, reducing the threat of flooding. So again, pretty unnatural looking. You need the space to be able to do it. All of these are relatively expensive, but this one particularly so because of the construction needed to build this safely. And you can see if there's roads in the way, you have to build bridges. Nevertheless, diverting the water away may very well help to slow the river down. One of the big issues though is this water's got to go somewhere. So the likelihood is it's going to divert through the urban area and then go back into the river. So the next settlement down the line may very well still get flooding. This may only impact this particular area. It might not help the rest of the river. We think about something like a dam can regulate the flow of almost an entire river if it's built far enough up. So a dam could be better in that sense. So your task now, to remind you, is to go back to copy and complete that table. On the next slide, we're going to get some answers to that, or a few of them, and you can use that as an opportunity to check what you've done. So pause the video here, rewind back to the table. You can go back through these again if you need. You've got the textbook to help, and get that filled in. Okay, answers. So I'll let you read through those yourself. There's more information than is just here. This is just some of the key information. So make sure you've got this down. But if you've got extra things, absolutely great. Well done. Good job. Hopefully you now have a good understanding of how these work, and you can start thinking about the social, environmental, and economic advantages and disadvantages of each of these strategies. And this is going to help us with our last task. Okay, so to finish, we're going to make a decision. Which hard engineering option do you think will be the best to manage flooding here, and why? Consider the social, economic, and environmental benefits. So this is a one-sided argument. I just want you to tell me what's good about the option you've chosen and why in this photograph it would fit this place. You've got the 4 options to choose from. There is no right or wrong answer. This is just an exercise in explaining and justifying a choice. Make sure that you do explain. So you will need to move a bit beyond, to do a good answer here, the notes you wrote in the table. You'll need to actually explain why those things are good. Think of the further impacts, socially on people, economically on jobs and income and money, and the cost of it would be included there, and finally on the environment itself. Try to cover a social, economic, and an environmental point if you can. Not always appropriate, but if you can, that would be great. Write this in full sentences, full paragraph. Almost imagine this is an exam question. This is a task by all means you could send to your teacher. This is something we'd love to see, and we could offer some feedback on as well. And that's the end of this lesson. So hard engineering methods, 4 of them completed. Next lesson we move on to look at soft engineering, and you will learn those 4. And we're very, very near to the end of this rivers topic, in fact. So take care. I shall speak to you soon.